We're talking about slope and writing and graphing linear functions. We want to be able to identify the linear equation, find the slope of a line given a graph or 2 points on a line, and write a line in point slope form given 2 points on a line. So here we have example. We want to write the equation of the line that passes through the given points. So the first thing we need to do is we need to calculate the slope. So whenever I calculate slope, I always put these things down first. I put the divide sign and I put the minus sign so I don't forget those. And then the next thing I do is I just write one of the coordinates down with the y in the numerator and the x in the denominator. And then I do the same thing again with the other point. Y is in the numerator, x is in the denominator. And that way I don't forget any of the signs that I'm supposed to have. So negative 2 minus negative 3 is negative 5. And then we can divide by 6 minus 1 is 5. And then we get negative 1 is the slope. So once we have negative 1 as the slope, then we can substitute it into our point slope formula, which is y2 minus y1 is equal to m times x2 minus x1. And basically, it's just the slope equation rewritten. But what we end up doing is we can substitute one of the points in. So I'm going to substitute in 6 minus 2 into one of the x values. And again, it doesn't matter which one. It can either be the first set or it can be the second set. It doesn't matter. So y2 minus y1 is negative 2. And that is equal to our m, which is negative 1, times x2 minus 6. So now that we have that written down like that, we can do a little bit of math and we can solve to get y by itself, and then we'll have it in y equals mx plus b form. So the first thing is we're going to distribute the negative 1 into the parentheses. So then we get y plus 2 is equal to negative 1x plus 6. And then we can subtract 2 from both sides. And then we get y equals negative 1x plus 4. And so,
negative x.
Yep. And so our slope is negative 1, and then our y-intercept is 4, and then it's in y equals mx plus b. So that is one way that we can do it. The trick for that is we have to remember this equation, which is the point slope form of the equation. Another way we can do it, the first step is the same. We have to calculate what our slope would be. And so whenever I calculate the slope, I always start off with m equals, and I put my minus signs to make sure I never forget those. And I'm going to pick this one to go in first, y in the numerator, x in the denominator. And then I'm going to pick this one to go second. So y in the numerator, x in the denominator. Then that will be equal to 1 minus a negative is positive, so that's going to be 4. and 5 minus a negative 5, that ends up being addition, so we get to 10, and then the slope can reduce to 2/5. Now, instead of using this formula that we used before, which was the point slope form, we can write it down as y equals mx plus b. Okay, and then we can pick one of the points in the slope and then calculate what our m is. Excuse me, what our b is. So I'm going to substitute 2/5 in. I don't know why I wrote 3. We're going to substitute 2/5 in for m. And then for the x value, I'm going to substitute in 5 and 1. So x is 5 and y is 1. And then we'll be able to solve for b. So 2/5 times 5, our 5's end up canceling, and we end up with 2. And then to get b by itself, we subtract 2 from both sides. And then we get negative 1 is equal to b. So we still have the y equals, and we still have the x. Now b goes in for our b value, which is minus 1. And our slope, which we calculated earlier, goes in for our slope in front of the x, or the coefficient for the x, and that is 2/5. So there are two different ways that we can do this. We can either substitute a point into y equals mx plus b and then solve to get b by itself, or we can use the point slope form, and when we solve for the remaining y, it just comes out as y equals mx plus b for us.